Previously, we defined a force as a push or pull. It is a vector quantity with a magnitude, units of Newton, and a direction. Furthermore, a contact force requires physical contact between two objects. It's time to introduce some new terms. In physics, a system is a group of one or more objects that we treat as a single entity. An external force is a force that the environment exerts on the system. On the other hand, an internal force is a force that one component of the system exerts on another component. Internal forces occur in pairs with the same magnitudes but opposite directions. To better understand these concepts, let's consider all of the forces involved when Lotus sits on a stool. She is pulled down due to Earth's gravity, and she is pushed up by the stool. The combined weight of Lotus and the stool push down into the ground. This is counteracted by a force from the ground, which pushes up against the stool. There are also forces holding Lotus's body together. For example, her arm has weight, so it pulls her shoulder down. Her shoulder pulls her arm up, so that it doesn't fall off. We can continue breaking everything down into smaller and smaller objects, which all interact with each other until we reach the atomic scale. By the end, we'll have a sore head from trying to comprehend an almost infinite number of forces. The trick to keeping things manageable and keeping our sanity is to define the system at the very start. For example, if we define the system to include Lotus only, then we only need to consider two external forces, a downwards weight force caused by Earth's gravitational field and an upwards normal force caused by the stool. We can ignore the forces between the stool and the ground because both objects are in the environment, so they are not part of the system. The forces connecting Lotus's arm to her shoulder act between two components of the system, so they are internal forces. They hold the system together, but they cannot make the system move or accelerate. Now, let's redefine the system to include both Lotus and the stool. This time, the external forces are the total weight of the system and the normal force provided by the ground. The forces between Lotus and the stool and the forces connecting her arm to her shoulder are internal forces because they act between the components of the system. When the stool pushes against the ground, the system exerts a force on its environment. This does not fall under any of our earlier definitions, so it is classified as neither an external nor internal force. To summarise, a system is something that we define when solving physics problems. Different systems may experience different types of external and internal forces. Next, we will consider compression. This is where a pair of external collinear forces try to squeeze an object and make it smaller. The word collinear means that the forces act in a straight line. A simple example of compression is when a person sits on a couch. To begin, let's define the system to include the cushion and nothing else. Ian's weight pushes the top of the cushion down, while the couch frame pushes the bottom of the cushion up. These are external forces because they are forces that the environment exert on the system. Furthermore, these forces are collinear because they occur in a straight line. On a smaller scale, atoms inside the couch are squeezed together. This is counteracted by an outwards push, which prevents the atoms from running into each other. To summarise, compression occurs when external forces point inwards and try to squeeze an object, while the internal forces point outwards and counteract the external forces. From everyday life, We know that solid objects cannot pass through each other. If you push really hard against something, it might break, but your hand will not end up inside the object. Only a ghost can pass through solid objects, but this is outside the realm of physics.